Okay, magandang umaga or magandang hapon. At dito sa video nito, i-discuss natin kung paano mag-solve ng problems related to shelf life determination from our raw data. So, ang ating data na gagamitin dito is yung ginamit sa experiment, yung experimental data. And i-cover natin sa video na ito is paano natin i-process yung data para lang magkameron tayo ng shelf life. Okay? So, a short discussion. In terms of our instrumentation na ginamit dun sa experiment is a UV-vis spectrophotometer. So, hindi ko na i-discuss kung paano gamitin ang UV-vis spectrophotometer. This will be reserved for your QC2 lecture and laboratory course. But what is important is these values that you would get from the experiment is absorbance. And absorbance is directly correlated with concentration. Anong sabihin nun? Pag mataas ang absorbance, mataas din ang ating concentration. So there is a way to convert absorbance to concentration. So you can convert absorbance to concentration. Ngayon, para ma-convert ang ating absorbance sa concentration. Ang absorbance class, yan yung makukuha natin sa spectrophotometer. Yung concentration, yung dinedetermine natin sa solution. Kailangan muna natin gumawa ng standard curve. So, ang isang standard curve ay para siyang reference point. It's a tool. Ang ginagawa dito, class, gagawa ka ng set of solutions na alam mo ang concentration. Kasi ikaw naglagay nung active ingredient. Gagawa ka ng set ng solutions na alam mo ang concentration. Then kukunin mo ang absorbance ng bawat solution. Take for example, gumawa ka ng in terms of milligram per ml. Naglagay ka ng 1, 2, 3, 4, 5. Gumawa ka ng gantong concentrations. Then kukunin mo ang absorbance. Pagpalagay na ito ay 50, 40, 30, 20, 10. So, yan ang isang standard curve. So, yan ang isang itsura ng standard curve. Para gumawa ng isang standard curve, ikaw mismo ang gagawa ng mga solutions na alam mo ang concentration, then kukunin mo ang kanilang absorbance. Ngayon, para saan ginagamit ang standard curve? Ginagamit natin ang standard curve para ma-convert natin ang ating absorbance into concentration. It is used to convert absorbance into concentration, even if the original concentration was absent in the initial curve. Okay? So, take for example, ito ang standard curve data na pinipare ko as a reflection of perfect experiment. So, kita nyo na alam natin yung concentrations. Okay, 0.2 mg per ml, 0.08, 0.04, pababa. And, i-determine natin experimentally ang absorbance. Okay, so yan ang purpose ng ating standard curve. Ginagamit natin ang standard curve to get concentrations that are not in the curve. Take for example, ang nakuha mong absorbance ay 2.000. Anong equivalent nun in milligram per ml? Okay. So, yun yung purpose ng ating standard curve. At ituturo ko sa inyo kung paano gamitin ang standard curve. Okay. So, ang una natin gagawin is this is a visualization of our standard curve. Okay. Ganyan ang itsura niya. It is a sort of straight line or a straight line pointing upwards just to point out that as absorbance increases, absorbance tong nasa Y, absorbance is Y, concentration is at X. As absorbance increases, our concentration also increases. So there is a direct correlation with our absorbance and our concentrations. So, paano ngayon natin gagamitin yung standard curve para computein or convert ang ating absorbance into our concentration? So, ang ginagamit po nating formula is our slope formula. So, however, in the method that I will be teaching you using your calculator, you will not be using the slope formula per se, but you will be using a version called the linear regression. So, these are actually the same two formulas. Y equals mx plus b, y equals a plus bx. So, the process is our linear regression. So, this is actually a more of a statistical tool to guess what value will correlate with a certain value. So, ang formula po is y equals a plus bx, or if x ang hinahanap, x equals y minus a over b. So here, y is our absorbance, a is our y-intercept, so this is obtained in the calculator, b is our slope, and x is our concentration. So in order to convert our concentration, our absorbance into concentration, you have to use this formula. Ngayon, paano siya ginagamit? Okay? So, tandaan niyo itong values na to ha. Y is absorbance, bago X is our concentration. Bago yung A at B class, huwag nyo nang intindihan kasi itong dalawang ito manggagaling sa calculator. Okay? So, paano natin gagamitin yung calculator? Okay? So, ito ang ating unang sample problem and how to use the calculator's linear regression function. So using the previous standard curve, determine the concentration of a solution with an absorbance of 0.12. So ang ating absorbance ay 0.12. So nandito dapat siya, around here. So around here, 0.12. So dapat in between these numbers, papatak yung ating concentration. Ngayon, hindi nyo kailangan magawa ng curve. Hindi nyo kailangan mag-drawing sa isang graphing paper. Ang kailangan nyo lang gawin is gumamit ng calculator. So, you're going to use a calculator like mine, or if you have a different calculator, you can research on how to use standard linear regression. But for this model of calculator, kailangan nyo lang gawin is set up, then stat number 3, then number 2, a plus bx. This is our linear regression. Okay? A plus bx is our linear regression. Okay? Ngayon, the calculator will ask you to place the numbers in x and y. Conveniently, nakaseparate naman yung ating concentration into x and y na. Yung data natin prepared na. So, ilalagay na lang po natin 0.2, 0.08, 0.04, 0.032, 0.17, 0.017, 0.0128, 0.0034, 0.00256. So we have actually 8 values for our curve. And may katumbas siya, kailangan class ay tama yung pag-input niya ng data. Otherwise, magugulo yung ating regression. So 2.886, 1.264, 6.677, 0.644, 0.322, 0.299, 0.11, and 0.02. Okay, pag na-plot nyo ng lahat, katulad yan, kita nyo naman po na lahat ng x ay may kapares na y. Kailangan, pwede nyo na siyang tanggalin. So, burahin natin. Pero, ang sunod nyo kailangan gawin is kunin ang a at b. Katulad na sabi ko kanina, ang a at b ay manggagaling sa calculator. So, paano yon? Kita nyo tong stat or distribution, shift, stat, yan, lalabas. So, type data sum variance regression. Makukuha nyo sa class sa number 5 yung regression data. So, lalabas ang A, lalabas ang B. So, kunin natin ang A. So, our A, 0.0923. 0923. 923. And our B, ganun ulit. Regression, B. 14.14. So, our slope is 14.14. Now, class, meron tayo ngayong absorbance. Okay? So, ang absorbance natin, class, ay nandito sa y. So, this is a y value. Y to. Kasi nasa absorbance siya, di ba? Ang absorbance ay y. Ang hinahanap natin ay x, which is our concentration. Ngayon, what is our formula for x? X equals y minus a over b. So, our x equals, ano ating y? 0.12. Yan ang ating absorbance. Ano ang ating a? Minus 0.0923. Then ano ating b? 14.14. And our x, let's compute. Sa calculator, class, pwedeng nakasave naman yung values. Katulad ng gagawin ko. 0.12 minus regression. Ano nga yan? A, no? A. Pwedeng ganun, pero medyo hassle. So, pwede rin diretsong yung values na. Okay? So, it is 0.195 times 10. 1.95. Purahin natin. Malinis. 1.95 times 10 to the negative third, or 1, 2, 3, 9, 5. 1, 2, 3. Ano? 1.95 times 10 to the third. Di kaya. .0195. Wala nga pala dito. 0.0195. So, siya ay dapat mas mataas siya ng konti sa 0.03. Okay, so let's continue from our example. Ito yung ating ideal data from our experiment. So we used we created a solution that was placed in different temperatures. Then, depende sa temperature, nag-iiba yung speed ng kanyang degradation. Ngayon, since hindi natin alam yung concentration, ang nakuha lang natin, class, ay absorbance. So, lahat ito ay absorbance. Okay? We now need to convert the absorbance into concentration data. Okay? So, gagawin lang po natin yung ginawa natin kanina. So, lahat ng ito ay gagawin nating concentration. Okay? So, paano natin gagawin yon? Let's, isa lang naman po yung standard curve na ginamit natin. So, our data from earlier. So, ating standard curve is still usable. Okay? Now, let's have it so. Ngayon, kailangan natin convert ang 1.763, which is a value of absorbance, into our concentration. So again, this is y. So to get x, y minus a over b. X equals 1.763. Ano ating value ng a? B to. So 14.14. then our A 0.0293 923. Lagyan ko na rin ito. Okay. So our X (0.118). So gagawa ka ngayon class ng bagong table in which burahin natin lahat ng nakasulat. So time 15. Anong katumbas niya sa 30? Anong concentration at 30 degrees after 15 minutes? So siya ay 0.118. Okay? Ano pong unit? Kung ano pong unit ng inyong standard curve. So milligram per ml po ang ating gagamitin. Okay? So gagawin niyo po yan sa lahat ng data. Iisa-isahin niyo yan. Okay? However, with the power of Microsoft Excel, madali lang yan with the power of Microsoft Excel. Okay, so ito na po yung ating converted na values. So ito, naka-milligram per ml na to. Now, we are to determine degradation rate constant. So what is degradation rate constant? So degradation rate constant, or our K. So this is actually equivalent to the slope of the concentrations, or letter B pag gamit yung linear regressions formula. Ngayon, hindi nyo na po gagamitin yung ating standard curve dito. Tandaan nyo class, ang gamit lang ng standard curve natin ay pag-convert ng absorbance into concentration. So lahat to naka-concentrations na. Okay? Iba naman po ang gagawin natin. Hahanapin natin ang degradation rate constant. Para makuha ang degradation rate constant, nandun naman siya sa ating regression eh. Sa ating regression formula na y equals ax plus b. B is our slope. Bx plus a pala. Sorry, bx plus a. Bx plus a. Bx y equals bx plus a, wherein b is our slope. Makukuha naman natin yan class sa ating table ulit. Gagawa lang ulit tayo ng bagong linear regression. This time, instead of absorbance and concentration, we're going to use time and concentration. Time versus concentrations. Okay? So, ang gagawin nyo class, para makuha ang degradation rate constant ng sa 30 degrees Celsius, sa 40 degrees Celsius, sa 50 degrees Celsius, at sa 60 degrees Celsius, ang gagawin ninyo ay ililinear regression nyo. So, ang mangyayari is gagawa kayo ng 4 na regressions. X at saka Y1, X at saka Y2, X at saka Y3, X at saka Y4. Okay? So, let's get the degradation rate constant for Y1. Okay? Kailangan nyo pong gumawa ng bagong linear regression. Okay? Hindi naman kailangan i-clear kasi pagpasok nyo doon sa regression ay automatic na siya mag-clear. Okay? So, ang ating X ay time. Ang ating Y ay yung concentration. So, 15, 30, 45, 60. Wala. 15, 30, 45, 60, 90, 120. Kanyang ka-pair. 0.118, 0.10, 0.107, 0.1051, 0.092, 0.08, 0.0532. Okay? Pag na-input nyo na class yung number, kailangan nyo lang kunin is yung letter B. Shift, stat, regression, and you should get letter B, which is our slope. So the slope value is negative 5.888 times 10 to the 4th. 1, tama po yan. 1, 2, 3, 4. Okay? Ngayon, itong degradation rate constant class, yan yung ating K. Pag nakuha nyo na ang K, you can now have access to shelf life saka half-life. Kasi, tandaan nyo, ang ating shelf life is 0.105 over K. Then, our half-life is 0.693 over K. Okay lang na mag-negative. Suggestion negative kasi pababa. Pero ang ating degradation rate constant, absolute value ang gagamitin nyo in terms of shelf life and our half-life. So what is the half-life of our drug in 30 degrees Celsius? Let's determine 0.693. 0.693 divided by our regression B. So 1176 time in minutes. So at a room temperature of 30, it would take 1176 minutes for it to reach 50% of the original concentration. If we choose to get instead shelf life 105.105, it is 178 minutes. So at this time, at 178 minutes, masisira na yung inyong gamot. Or expired na, technically expired na inyong gamot at 178 minutes. So for the experiment kasi, hindi ko nakakompute yung iba. But to get these values, you have to get their slopes. Prepare nyo ulit ang x sa bawat y. Please take note na hindi nyo pwedeng pagsamasamahin yung concentrations galing sa iba't ibang temperatures kasi maghahalo ang data nyo. So, x, y1, x, y2, x, y3, x, y4. Okay?